Welcome, everyone. Ready to dive deep into the hunt for planets beyond our solar system. Exoplanets.
Yeah.
We're talking about a cosmic revolution that's happened in just the last few decades.
Yeah, it really is pretty incredible.
It wasn't that long ago that planets around other stars were pure science fiction.
You're right. It's amazing to think about.
And our source material for this deep dive takes us back to the very first discoveries, starting in 1992,
Okay. Yeah.
with Alexander Wolzan and Dale Frail finding planets
Uh-huh.
orbiting a pulsar.
Interesting.
Now, a pulsar, that's not your typical star, is it?
Oh, definitely not.
So tell us.
Pulsars are these super dense, rapidly spinning neutron stars.
Oh, wow.
Left over from supernova explosions.
Right.
Not exactly where you'd expect to find planets.
Right.
Let alone life as we know it.
Yeah.
But that's what makes this finding so important.
Uh-huh.
It was proof that planetary systems could exist in the most unexpected places.
So it was less about finding a twin Earth and more about shattering our assumptions of where planets could form.
Yeah.
Okay, and then just a few years later,
Yeah.
in 1995, Michel Mayor and Didier Queloz made another groundbreaking discovery, 51 Pegasi b.
Right.
This time, the planet was orbiting a star much more like our sun.
That's right. Yeah, much more like our sun.
Now, that must have gotten everyone really excited.
Oh, absolutely. 51 Pegasi b, that was a game changer.
Yeah.
Our first confirmation of a planet orbiting a sun-like star.
I see.
And it really ignited the search for these potentially habitable worlds like our own.
Okay, and that search has been wildly successful. Our sources tell us we've identified over 5,000 confirmed exoplanets.
Oh, yeah.
Thanks to missions like Kepler and TESS.
Yeah, those are big ones.
And what's remarkable is the sheer variety we're finding. Gas giants bigger than Jupiter,
It's incredible, isn't it?
rocky planets like Earth,
Uh-huh.
and even planets orbiting two stars.
Oh, yeah, like Tatooine.
Wait, double sunsets?
Like in Star Wars.
Are you telling me science fiction is becoming reality?
Well, in some ways, yes. We're finding planetary systems that challenge everything we thought we knew about how planets form and how they behave.
I bet that's causing quite a stir in the scientific community.
Oh, it is.
Yeah.
You know, these discoveries are forcing us to constantly reevaluate our theories
Okay.
and models of planetary formation.
So we've got thousands of these exoplanets,
Yeah.
some with mind-boggling characteristics.
It's really an exciting time to be studying exoplanets.
But the question that's on everyone's mind is, could any of them harbor life?
Well, yeah, I mean, that's the ultimate goal, isn't it?
Right, and that's where this concept of the habitable zone or the Goldilocks zone comes into play.
That's right, yeah.
It's the region around a star where temperatures are just right
Mm-hmm.
for liquid water to exist on a planet's surface.
Right.
Liquid water, the essential ingredient for life as we know it.
Absolutely.
But being in the habitable zone doesn't guarantee a planet can support life, right?
Well, that's right, yeah.
Okay, so there's more to it than just being the right distance from a star.
You also need
Okay.
the right atmosphere, a stable climate, and a suitable chemical composition.
I see.
A planet in the habitable zone could still be a barren wasteland if those other factors aren't in place.
So even in this Goldilocks zone, things could be
Yeah.
too hot or too cold in a way?
Yeah, exactly. It's about a delicate balance.
Hmm.
And keep in mind, we're defining life based on what we know from Earth.
Right.
Life elsewhere could exist in forms we haven't even imagined,
Right.
potentially thriving in conditions we consider inhospitable.
I mean, that's a truly mind-blowing thought.
Right.
It makes you realize how much we still don't know.
Absolutely.
But let's get back to what we have found.
Yeah.
Our sources mention some particularly intriguing exoplanets.
Oh, yeah.
One that stands out is Kepler 22b.
Right.
It was the first confirmed planet orbiting within the habitable zone of a sun-like star.
Yes.
What's particularly interesting about Kepler 22b
Yeah.
is that it's significantly larger than Earth,
Yeah.
about 2.4 times the radius.
Oh.
Wow, a super Earth.
Yeah, a super Earth.
What are scientists thinking about its possible environment?
Well, its size suggests it could be a rocky planet with a thick atmosphere, possibly even a global ocean.
Oh, wow.
Some theories suggest it might have a runaway greenhouse effect, making it too hot for life as we know it.
Okay.
But until we can study its atmosphere in more detail,
Yeah.
it remains a tantalizing possibility.
I'm already picturing vast alien seas on Kepler 22b.
I know, right?
Okay, what other candidates have piqued the interest of scientists?
Let's see. Another one is Kepler 452b,
Uh-huh.
sometimes called Earth's cousin,
Okay.
because it orbits a star very similar to our sun and resides in the habitable zone.
So this one's in that sweet spot for liquid water, too.
That's right.
But again, it's all about gathering more data.
Yeah, we need more data.
And that brings up another question. How do we actually find these exoplanets?
Right.
We can't exactly hop on a spaceship and go visit them.
No, not yet, at least.
At least not yet.
That's where the ingenuity of our detection methods comes in. One of the most common techniques is the transit method.
Okay.
So imagine you're watching a star from far away,
Yeah.
and a planet passes in front of it, like a tiny eclipse.
Okay, I'm picturing it.
That planet blocks a tiny fraction of the star's light, causing a dip in its brightness. And we can measure that dip with incredible precision and use it to calculate the planet's size and orbit.
So we're not directly seeing the planet, but we're seeing its shadow, so to speak.
Exactly.
Wow.
And by analyzing the light that passes through the planet's atmosphere during a transit, we can even glean clues about its composition.
Wow. It's amazing how much information we can get from these subtle changes in starlight.
It really is remarkable.
And that's just one of the methods we use to find exoplanets.
Yeah, there's also the radial velocity method,
Okay.
which relies on detecting the wobble of a star caused by the gravitational pull of an orbiting planet.
So in a way, we're seeing the star dance to the tune of its planetary companions.
That's a great way to put it.
I like that.
And then there's direct imaging,
Okay.
which is the most challenging but also the most visually rewarding.
Direct imaging. So we're actually taking pictures of these distant worlds.
We are, but it's incredibly difficult.
Wow.
Planets are incredibly faint compared to their stars.
Yeah, I can imagine.
Imagine trying to spot a firefly next to a spotlight.
That sounds incredibly challenging.
It is.
Yeah.
But our technology is constantly improving, and we're developing telescopes and instruments capable of capturing these faint whispers of light.
So we have these incredible tools and techniques.
Revealing the secrets of planets light years away.
And we're finding all these fascinating planets.
It's incredible.
But what's the next big leap in exoplanet research? What's on the horizon for unlocking even more secrets about these distant worlds?
Well, one of the most exciting frontiers is the study of exoplanet atmospheres. You know, we're moving beyond simply detecting these planets to actually analyzing their air, understand their composition and history.
This sounds like the next chapter in our exoplanet adventure, and I, for one, can't wait to dive in.
Me too. It's fascinating stuff.
All right, we'll be right back after a short break.
It's like getting a glimpse into their past, present, and future.
Oh, wow. Their past, present, and future.
Yeah, it's incredible what we can learn from the air around these distant worlds.
I can only imagine. So what kind of stories are these atmospheres telling us?
Well, for starters, they can reveal a planet's history.
Okay.
Things like volcanic activity, asteroid impacts, even the presence of oceans.
Oh, wow.
All of these leave their unique fingerprints on the composition of the atmosphere.
So it's almost like planetary archaeology.
Yeah.
But instead of digging in the dirt, we're studying the air.
Right. That's a great analogy.
I like that.
And here's where it gets really interesting. Analyzing the atmosphere can also give us clues about a planet's climate and its potential for supporting life.
Now we're getting to the heart of the matter.
Exactly.
So how exactly can we tell if an exoplanet might be habitable just by looking at its air?
Well, think about it this way. On Earth, our atmosphere is teeming with life.
Okay. Yeah.
The air we breathe.
Yeah.
It's a product of billions of years of biological processes.
So you're saying we can look for similar signs of life in the atmospheres of other planets?
Precisely. Certain gases like oxygen, methane, even more complex organic molecules can be indicators of biological activity.
So finding oxygen in an exoplanet's atmosphere, that would be like finding a giant neon sign flashing life.
Well, it would be pretty exciting.
Yeah.
But it's not quite that simple.
Okay.
We have to consider the context, the planet's overall environment, and the possibility of non-biological processes producing those gases.
So it's about looking for the right combinations of gases?
Yes.
And making sure we're not jumping to conclusions.
Exactly. It's a meticulous process, but incredibly rewarding. Imagine being the first to discover evidence of life on another world just by studying its atmosphere.
That would be incredible.
Talk about a groundbreaking discovery.
But let's back up for a second and talk about the tools we're using to analyze these exoplanet atmospheres.
Okay, yeah.
One that immediately comes to mind is the James Webb Space Telescope.
Oh, of course, yeah, the James Webb.
Its incredible sensitivity allows us to study the light passing through exoplanet atmospheres.
It's amazing.
An unprecedented detail.
It really is a game changer.
So we're using the same telescope that's capturing those stunning images of distant galaxies to sniff out the air on alien planets.
We are. It's incredible, isn't it? It's a testament to the versatility and power of the James Webb.
Wow. And as our technology continues to advance, we're developing even more sophisticated instruments and techniques for studying these distant atmospheres.
It's an exciting time.
It feels like we're really pushing the boundaries of what's possible.
Absolutely.
All of this is amazing, but I have to ask, are there any limitations?
Well, of course.
To what we can learn from atmospheric analysis?
We're still limited by the technology available.
I see.
Even with the James Webb, it's challenging to study the atmospheres of smaller rocky planets like Earth.
So we're better at studying the atmospheres of larger planets?
For now, yes. But as our instruments become even more sensitive, we'll be able to probe the atmospheres of smaller worlds in greater detail. It's just a matter of time.
It sounds like patience is key in this field.
Patience and perseverance.
Yeah, we're building upon each discovery, each technological advancement.
Absolutely.
Taking us one step closer to answering that fundamental question. Are we alone?
That's the big question, isn't it?
Yeah.
And you know, the search for life beyond Earth isn't just about finding another planet that looks like ours.
Okay.
It's also about understanding the incredible diversity of planets out there.
You mentioned this earlier. The mind-boggling variety of exoplanets we're discovering.
Oh, yeah, there's so much out there.
Can you tell us a bit more about some of the more unusual types of planets?
Well, take hot Jupiters, for instance.
Oh.
These are gas giants, like Jupiter, but they orbit incredibly close to their stars, much closer than Mercury orbits our sun.
So close that they must be scorching hot.
Exactly. They have incredibly short orbital periods, some whipping around their star in just a few days.
Wow. A year that lasts only a few days.
And their atmospheres are blasted with intense radiation.
Intense radiation.
Creating some truly extreme environments.
It's fascinating how a planet so similar in size and composition to Jupiter can exist in such a dramatically different environment.
I know, right? It challenges our assumptions about what a planet can be.
What else have we found out there?
We've discovered mini Neptunes.
Mini Neptunes, okay.
Planets smaller than Neptune but larger than Earth with thick atmospheres composed mainly of hydrogen and helium.
Wow, so many different types of planets.
We're also finding super-Earths.
Super-Earths?
Rocky planets significantly larger than our own.
Okay, super-Earths.
And we're still trying to figure out what conditions might be like on their surfaces.
All this talk of hot Jupiters, mini Neptunes, and super-Earths, it sounds like our solar system is starting to look kind of ordinary in comparison.
Well, in some ways, yes.
Yeah.
We used to think our solar system was the blueprint for how planetary systems should be organized. But exoplanet discoveries have shattered those assumptions.
So instead of finding a mirror image of our solar system, we're finding an incredible cosmic zoo of planets.
That's a great way to put it.
I like that.
We're seeing planetary systems with architectures and configurations we never could have imagined before.
And that's what makes this field so exciting.
It's truly mind-blowing.
Out of all these discoveries, what has surprised scientists the most?
One of the biggest surprises has been the sheer number of planets out there.
Okay.
Our galaxy is teeming with them.
Wow.
We're finding planets around nearly every type of star we look at.
So planets aren't the exception. They're the rule.
It's starting to look that way.
That changes things.
And that has profound implications for our understanding of the universe and the possibility of finding life beyond Earth.
It makes you wonder what other surprises are lurking out there, just waiting to be discovered.
I know, it's so exciting to think about.
So what's the next frontier in this cosmic quest? What are scientists focusing on now?
Well, one of the most promising areas of research is the search for Earth-sized planets in the habitable zones of their stars.
So instead of just looking for any planet, we're getting more targeted in our search.
We are. Missions like the upcoming Plato, which is set to launch in the late 2020s, will be able to measure the properties of Earth-sized planets with incredible precision.
Wow, the late 2020s, that's not too far off.
I know, it's coming up quickly.
Yeah.
We'll be able to determine their size, mass, density, and even get a glimpse of their atmospheres.
That sounds like a giant leap forward.
It really is.
So we're not just finding these planets, we're starting to understand them in much greater detail. But what does all of this mean on a larger scale?
Well, exoplanet discoveries are revolutionizing our understanding of our place in the cosmos. For centuries, we thought our solar system was unique.
Yeah.
Now we know it's just one of countless planetary systems scattered throughout the galaxy.
It's humbling, isn't it?
It really is.
To realize that we're part of something so vast and complex.
It makes you feel small, but also connected to something much bigger than ourselves.
Yeah.
And it all started with looking up at the stars and wondering what might be out there.
That's the beauty of science.
It is.
It starts with curiosity, with asking questions.
And those questions lead us to incredible discoveries that reshape our understanding of the universe and our place within it.
It's a journey that never ends.
No, it doesn't.
Speaking of journeys,
yeah,
we've covered a lot of ground in this deep dive.
We have.
From the first exoplanet discoveries to the search for signs of life in distant atmospheres, it's been quite an adventure.
It really has.
But before we wrap things up, I have one final question that's been nagging at me. With all this focus on what's out there,
Yeah.
what about us? How has the discovery of all these other worlds changed our understanding of Earth?
That's a great question.
Yeah.
It gets to the heart of why exoplanet research is so important.
Okay.
It's not just about finding another Earth.
Huh.
It's about understanding our own planet in a whole new light.
Can you give us an example of that? Like, how does looking outward help us understand what's right here under our feet?
Well, take the example of Venus.
Okay.
It's often called Earth's evil twin because
Okay.
it's similar in size and composition.
Okay.
But its atmosphere is a scorching inferno, hot enough to melt lead.
Yeah, I wouldn't want to spend a summer vacation there.
Right.
Yeah, but what does Venus have to do with understanding Earth?
Well, by studying what went wrong on Venus,
Okay.
how it developed a runaway greenhouse effect,
Uh-huh.
we can gain insights into the delicate balance that keeps Earth habitable. It helps us appreciate the factors that regulate our climate and the importance of protecting our atmosphere.
So in a way, these failed planets can teach us just as much as the potentially habitable ones.
Absolutely.
Okay.
Every exoplanet we discover, whether it's a scorching hot Jupiter or a frigid ice giant,
Yeah.
adds to our understanding of the processes that shape planets and the conditions necessary for life to arise.
It's like each planet is a piece of a giant cosmic puzzle.
Yeah.
And the more pieces we find, the clearer the picture becomes.
Exactly.
But with so many planets out there,
I know, right?
so many possibilities, where do we go from here? What are the big questions that still need to be answered?
Well, one of the biggest questions is whether we're alone in the universe.
That's the big one.
And we're getting closer to answering that question with each new exoplanet discovery
Okay.
and with advances in our ability to analyze their atmospheres for signs of life.
I can only imagine what it would be like to find definitive proof of life on another world.
Oh, it would be incredible.
It would fundamentally change our understanding of our place in the cosmos.
Absolutely. One of the most profound discoveries in human history.
Yeah.
But even if we don't find extraterrestrial life,
Yeah.
the search itself is transformative.
Mm.
It's pushing the boundaries of science and technology,
Uh-huh.
and it's inspiring generations of scientists and explorers.
And it's capturing the imaginations of people all over the world.
It really is.
Yeah, it's not every day that we get to witness a scientific revolution unfold in real time.
It's an exciting time to be alive.
That's what makes this field so exciting.
And it's not just about professional scientists.
Okay.
Amateur astronomers are playing an increasingly important role in exoplanet discovery,
Really?
contributing valuable data and observations.
So anyone with a telescope and a bit of curiosity can join in the search for other worlds.
Absolutely.
That's pretty cool.
There are citizen science projects that allow anyone to participate in analyzing data from telescopes, searching for the telltale signs of planets orbiting distant stars.
That's fantastic.
It is.
It really democratizes the process of scientific discovery.
It does.
Well, we've covered a lot of ground in this deep dive, and I have to say, it's left me feeling both humbled and incredibly inspired.
Me too.
It's a reminder that we're living in a remarkable time where we're not just dreaming about other worlds, but actually discovering and studying them.
I know. It's incredible.
It's an adventure that's only just begun.
And to our listeners out there, we hope you've enjoyed this journey as much as we have.
Keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the universe.
Who knows what amazing discoveries await us just around the cosmic corner?
That's right. Until next time.